So now, the Zener diode, we got one right there. There's a lot of diodes that look like this though. You got to read the part number, but also you can check it the way that we're going to right now. So this is a 5.6 volt Zener diode. If you look at it closely, you'll see 5V6 right there for its value. They take the V for voltage and put it where the decimal point is because you might not see the decimal point in like handwritten form and on small components right there. You need to get current flowing through the Zener diode though to get its Zener voltage. So it won't conduct until you get about 5.6 volts across it. That's why you need a higher supply voltage. But after that point, it's going to conduct as much as needed to maintain 5.6 volts across it. And it's not precise. It does change just a little bit with how much current's flowing through it. The more current flowing through it, the higher voltage you get. But for the most part, it's going to be really close to 5.6 volts. We're going to look at that coming up. So I put 7 volts to 12 volts, and we could go even higher. I think maybe 15 would be the limit. But any case, that's what we got there. There's a schematic diagram. Remember, the cathode is more positive. The anode is more negative when you are using a Zener diode to get its Zener voltage right there. And the amount of current that's going to flow through is based on the supply voltage and the current limiting resistor you use. If you use 1K, you're going to get 1 milliamp of current for every volt that is higher than 5.6 volts in this case right there. The output is not for powering a load. That's not how you get 5.6 volt power source. You could send it to an amplifier, which looks at this voltage and provides a power voltage, but this is just a reference voltage for other circuitry to look at. So now, one way to find out its Zener voltage, and also just to show its Zener voltage in video, we can measure with the multimeter there. So this is auto ranging. I just have to set it to V. I don't have to move the red probe for voltage, only if I'm going to measure high current. So first we can look at the supply voltage. It is set to 7 volts, if that's showing up on screen, however you are watching this. And so yeah, down to 7 volts, our minimum that I put on the sheet right there. Now we can go across the Zener voltage. So black probe is the negative supply, which has a jumper going to the anode of the Zener diode. Remember, you got to do it reverse bias. So that's a little bit lower than what we kind of expect. But, you know, still pretty close to 5.6 volts. And, you know, if it's not a precision circuit you're doing, that's just fine. And then we got 1.4 volts across a 1,000 ohm resistor. So that's 1.4 milliamps of current that's flowing through both these components. The voltage across the resistor is what will be setting the current. So I put 12 volts as the maximum voltage up there, and on the sheet, we'll look at that. So now I got 12 volts, and we'll see right there, it's a little bit above 5.6 volts. So there we go. Now it's, you know, depending on how we get the connections, gonna impact it a little bit, but not a lot. And we'll see that, you know, about 6.34 milliamps of current. So probably about 6 milliamps of current you want to get through the Zener diode to get it really close to its 5.6 volt Zener voltage. And so again, if you attach other circuitry to it, just like with the meter, you don't want to draw any current away from that connection right there. You want all the current to be going through the Zener diode, and then that will set its Zener voltage. You're just looking at that voltage for other circuitry to respond to. Turn off the meter when you are done.